get started. I'm Heather, and I have my coworker Christa with me today. We're both product engineers on the Network Analyst team, and today we'd like to talk to you about routing your fleet of vehicles. We have a growing number of solvers to help you divide up the locations that need to be visited, and we want to introduce those to you today. But first, please take a few minutes at the end of our presentation to fill out our survey. I'm sure you've heard that a lot today. But my team would really like to present more at this conference, and we're not going to get approval for more if you don't give us a good response rate. It can be terrible responses, but give us at least a good response rate. Okay, so today we're going to cover 4 of the Network Analyst solvers: route, vehicle routing problem, last mile delivery, and waste collection. For each of these, we're going to give you the basics about them, what part of the platform they're available, some benefits and considerations, and then Christa will give a demo for each. Afterwards, we'll review which solver is the best one for your needs, and then open things up for some questions. So the Network Analyst capabilities are expanding. We have capabilities such as location allocation to help decide what facility to select, or service area to see how far you can travel from a store by foot or maybe driving. We also have some newer capabilities such as taking the route GPS tracks and finding the route along our street network that the driver actually took. But today we're going to focus on just 4 of them: route, vehicle routing problem, last mile delivery, and waste collection. These 4 are tied together in that they're all able to do fleet routing. So let's define fleet routing a little bit better. By this, I mean that there are multiple vehicles, and each one is going to be routed to multiple locations. Think about a fleet of vehicles and their drivers traveling to work sites throughout the full day. And if you're using Network Analyst in the traditional sense, then these vehicles are traveling along a street network. With a street network, we would account for rules of the road. Some examples of this would be making sure a tall truck doesn't get stuck under a low bridge, and a heavy truck stays off the small local roads. We've certainly helped people create networks that aren't traveling along streets, but that is not the purpose of this presentation. So if you've got questions around that, come talk to us afterwards or meet us in the tech zone and we can talk through that. Network Analyst has capabilities across the whole Esri platform of both software and software as a service. ArcGIS Pro is our premier desktop software with full UI capabilities, allowing for very interactive workflows. Because of the visualization capabilities that are inherent within ArcGIS Pro, that's where we're going to do our demos today. And although that's its main strength, it also has automation capabilities through both Python and Model Builder. The other options open up more automation through the REST API. ArcGIS Enterprise would require having the Network Analyst extension and your own network data set. Whereas ArcGIS Online or ArcGIS Location Platform would use credits. We commonly see customers make a decision between these two based on 2 things. 1, how much are you going to use Network Analyst? And 2, do you have to have your own network for some reason? But in all likelihood, your organization's already made this decision for you. Okay, so let's start with the route solver. The QR code here will get you to our developers' documentation for it. The route solver is used for finding the best path from one location to the next. There's the option to have the solver determine the best sequencing, known as the traveling salesman problem, or you can provide the sequence to create a series of point-to-point routes. A single route solve, though, can have multiple routes within that problem. The route assignment, though, is fixed and predetermined by you. So our route solver can be used across the platform. This gives you choices based on your application's other needs. So let's dive a little deeper. The route solver is very fast and it's easy to set up, and you have the option to use it across your whole platform. However, some things to consider on deciding if this is the right solver for you are that the route assignments are going to be set and determined by you instead of being optimized. And also, if you're going to optimize the sequencing, that's going to be on either time or distance, but not both. Christa, how about a quick demo of the route solver?
Thanks, Heather. So for this demo, we're going to take a look at using the route solver to route 3 commuters from their homes to their separate workplaces. Each commuter has a unique origin and a unique destination, and we need to optimize the route for each. So let's get started. So here I have a layer with our commuters' home locations, and I'm going to right-click and open the attribute table so we can look at the data more closely. You can see we have a name field with our commuters' names, Rain, Sandrine, and Vito. And now I will open the attribute table for our work sites. And you can see we have an employee field that references the names in our commuter field. And the name here with the work site names, Coffee on a Break, Lobster Shack, and Pivot Furniture. Okay, so I've already created a route layer in this map, and I'll select it and go to the ribbon to import stops. When the Add Locations pop-up opens, first I'm going to select the commuters layer from the dropdown. Then I'll just make sure name is mapped to name and route name is mapped to name, which is our employee name here for the route name. I'll hit apply so that this window stays open. And I'll just move it so that it's easier to see our map. And then I'll just zoom to the layer. So you can see we've now added these blue stops on each of our commuters. And you notice there's a 1 next to each, meaning it's the origin for each of 3 separate routes. So now select work sites, and name will map to name again, but for route name, I want to map to employee name. That'll connect these stops to our other stops. So they both have employee name as route name. Okay, so I will just hit run, and you can see our 3 routes get drawn on the map in different colors. And I'll close these tables so you can see the map better. And you'll see that we have Vito's route here in purple, and Rain's commute here in blue, and Sandrine's commute in green. And I'll just open the attribute table for our routes so you can see some additional information on the 3 routes generated. Including if we scroll over this info on total travel time in minutes, which has been optimized for each commuter. Okay, back over to you, Heather.
Great, thanks, Christa. All right, let's move on to the vehicle routing problem solver, abbreviated as VRP. The QR code here will take you to the developer site for it. The VRP solver will optimize both the route assignment and sequencing. We think of this as sort of our multi-tool solver, as it has a lot of modeling options that fit many different use cases. Some examples are medical transport services, picking up documents from one location and delivering to a second, and appliance repair. The VRP solver is also available across the platform, giving you lots of modeling options. While the VRP solver is great for its versatility, it has some modeling constraints not available anywhere else. This versatility can also be a hindrance, though. It can be quite complex to get that model set up correctly. We also see a dramatic quality and performance degradation over 3,000 orders for this. So if you're going to use the vehicle routing problem, we think the smaller sizes are better for this option. Christa, can you explain why this adorable raccoon is waving at us?
Sure, Heather. In this demo, we're helping an urban wildlife rescue team respond to multiple emergency calls across San Francisco. Each call involves an injured animal waiting at a pickup location, and each animal must be transported to a specific care facility equipped to treat that species. For example, a hawk needs an avian specialist, while a raccoon or a coyote must go to a clinic or rescue specializing in larger mammals. Because every animal has a unique destination, we can't treat these stops as interchangeable. The pickup and its matching drop-off must be routed together as a pair. So in this demo, we will use paired orders. They tell the solver these 2 stops are linked, they must be assigned to the same vehicle, and they must be visited in the correct order, pickup first and delivery second. Without paired orders, the solver might optimize purely for efficiency and accidentally break these relationships. By defining each pickup and delivery with a shared pair ID, we allow the solver to optimize the entire route network while ensuring each animal reaches the right care center. So in this demo, we'll work with 10 of these rescue pairs in ArcGIS Pro. So let's get started. Let's look a bit at the data that we're using. I started with this table, And the table contains different reported injured animals that we need to deploy drivers to pick up. You can see we have lots of kind of animals all over the city, from pigeons to coyotes to raccoons. And then we have an address or intersection associated with each pickup, a unique identifier for the rescue location, an address for that, our time windows where the animals must be delivered, total passengers allowed in a vehicle, which will be 1, and a max transit time of 90 minutes that they can be in the van. Okay, so I use that table to geocode our animal locations so we can visualize them on the map. You can see we have our animal locations all over the city, and then I use that same table to geocode our animal rehab locations. You can see those on the map as well. And then I also have this layer here with our central depot for our wildlife transportation vehicles designated with the star, and that's where all vehicles will start their day. Okay, so I've added the vehicle routing layer problem to the problem layer to the map, and we'll just set it up to make use of order pairs. So we'll import our orders starting with our animal location, which is that geocoded table. And I'm just going to map my fields. So name will be mapped to that unique identifier, user underscore order name 1. And then for description, I'm going to map it to our address, which is user underscore animal location. And then next, I'm going to map our time windows. And as I'm mapping these, if you notice that I've got that all caps user underscore prefix, those are just fields, or that prefix is added during geocoding. It just designates which fields were in my original table. So, and then we add that prefix during geocoding. Okay, so then I'm going to map our pickup quantity 1, because our animal locations are our pickup locations, to user total passengers. And then for service time, I'm going to add a default value of 10, meaning it'll take 10 minutes to load the animal into the van. And I'll set a max violation time to 0. And I'll hit apply just to apply all of those and add the locations and keep that window open. You can see those black points added over our animal locations. Now I'll do the same things for our animal rehab locations. So we'll select that layer, just map some fields. I'll map name to order name, user order name 2, which is our unique identifier for each animal rehab drop off. And then for description, I'll do user animal rehab address, which is the address for our rehab facilities. Now I'll map delivery quantity, because these are our delivery locations, to that user total passengers again. And the rest of these, I'll just use our defaults, and I'll hit OK, so those get added and it closes. And now I will import our ordered pairs. This little drop down here, I'll click Import Order Pairs. And then from that, I'm going to just import them from our original table. So come down to this Excel table, and I'll just make sure our unique identifier is mapped to first order name, second order name, and max transit time, and hit OK. And now I will import our depot. So I'll select that central depot layer and just check that name field mapped and hit OK. Okay, now I've already gone into the routes sub-layer here, and I'll just show you in the attribute table. I've populated it with information on our 3 vans. Those all start and end at our downtown depot, and they've each got a start time and latest start time that they can leave that depot in the morning. Okay, before running, I just want to check some overall settings. I'll make sure mode is driving time, our time units are minutes, our distance units are miles. I'm going to set default date to day of the week and Wednesday for today. We want to travel along the network. And then under clustering, I've turned that off because we just want to prefer the best route for every van, and we don't care if they stay in the same neighborhood for this one. So I will hit run, and we'll see our routes display on the map. And you can notice that we can actually complete all our pickups and drop-offs with just our van 2 and van 3. So even though we have 3 vans, it was able to do all of this really efficiently with just the 2. So we'll just use those 2. And just to show you a closer look of how those routes look, make sure they're doing the right thing. Our van 2 will leave the downtown depot, and it will go to our pickup coyote location. We'll depart the pickup coyote location, then it should drop that coyote off before it picks up another animal. Okay, so it arrives at the Coyote delivery, it will depart the Coyote delivery, and then you'll see that it arrives at our Fox pickup next. So by looking at all those directions, we can see that it's doing exactly what we want it to, picking up an animal and then dropping it off at its location before going on to the next order. Okay, back to you, Heather.
Thanks, Krista. I'm glad all those animals got safely to the clinic for treatment. All right, let's switch to the last mile delivery solver, abbreviated LMD. The QR code here will take you to the developer documentation for it. The LMD solver is the first of our use case specific solvers. This one was designed around the package delivery problem, helping companies with that last mile of going from a distribution center to the customer location. The basics of the problem this is designed to model is there's just a single distribution center or store that are gonna go to all of the delivery locations, those customer locations, and we're targeting about 100 on a route. This is typically planned the night before as a pre-planning process, and we have some capabilities in place to allow for that dynamic addition the day of. Last mile delivery has been available across the platform a little over a year, but I know some folks get stuck on older versions for reasons that are often not their own choice. So I included here the version and release time available to give you some valid requirements to take back to your boss for getting things updated. The LMD solver is able to solve very large problems, and we scale nearly linearly with the number of orders in the problem, so we actually solve those large ones pretty quickly. The solver are focused on clustering the route assignments for orders so that the drivers stay within the same neighborhood for their full route instead of crisscrossing with the other drivers. We're very proud of the quality and performance of this solver, and so we recommend that if your constraints fit within the solver's capabilities, then this is the solver for you. Alrighty, I know we're getting close to dinner time, so Krista, how about a demo that makes us think even more about food?
I can do that. Okay, so a family-owned cheese shop in Paris has recently modernized its operations and begun offering early morning cheese box deliveries to artisan bakeries across the city. The bakeries rely on these fresh cheese assortments to prepare lunch boxes for picnics. Demand has grown quickly, and each bakery now places its own order for cheese boxes, with quantities varying based on neighborhood foot traffic. To keep all operations aligned across the city given the morning business hours, the cheese shop must complete its deliveries within tight time windows, and delivery vehicles have a max cheese box capacity. So planning the right number of routes and aligning them with each bakery's time window is essential to keeping the operation running smoothly. So we'll use last mile delivery to handle this operation. Okay, so here in Pro, I already have loaded my data and set it up in this LMD layer, and I'll just walk you through what I have added to the map here. In orders, if I open the attribute table, what I have is my bakeries. So we have our name for each bakery, the service time it takes to drop the cheese off there. We have our time windows, meaning when they need the cheese by each morning, and the cheese box quantity that needs to be delivered to that bakery. Okay, so next we have our depot sublayer, and this is essentially our cheese shop. That's where all of our delivery vans will be taking their cheese out to all of the bakeries. And under routes, we have information on our vehicles. Okay, so it's preloaded with our 5 delivery vans. They start and end at our depot, which is listed here. They have a start time for the day, and each van has a cheese box capacity of 50. Okay, so now I'm gonna go up to the LMD ribbon and run this, and you'll notice how quickly it solves for all of these deliveries. One thing I do want to point out is that I added a sequence gap of 10 between our stops right here. And the reason I did that is if we're putting this in and solving for it at night, we have a gap of 10. If we get any deliveries in the morning, that gives us space to drop 10 orders in between our existing orders and resolve. So you can see our colored routes here are all clustered by default. That's the way that LMD will solve. And just really quick, I want to show one other way that you can make use of last mile delivery. We have this doc page, and this is actually running on source code within the page, but you can set all of these parameters dynamically in the page and kind of play around with it and see how it solves. But the cool thing about this is you can actually copy the source code directly from this documentation page and modify it and build your own custom app to play around with how last mile delivery works in a web browser as a custom app tool. Okay, back to you, Heather.
Great, thanks, Krista. I'm personally invested in cheese getting properly delivered to those bakeries, as I love a good picnic. Okay, so let's switch over to our last solver, the waste collection solver. The QR code this time is going to take you actually to our ArcGIS Pro documentation, highlighting our Python capabilities for it. The waste collection solver is for residential waste collection to grab the bins from every house. The solver divides the houses to trucks and provides a suggested sequencing for collecting them. To account for requirements that we've gathered from cities, we'll send one route to collect all the houses on one side of a street edge. So think of a block or a section of street between two intersections. We also strongly prefer that both sides of the street are collected by that same truck, but we don't make that one the hard requirement. So at the current moment, waste collection is only available on ArcGIS Pro and only since version 3.5. However, there's still that Python option available for automation while we work on expanding it across the whole platform. So the waste collection solver is definitely the solver for you if you have the density that is every house on almost every street. This solver does some internal aggregation to allow for the density of the problem to be solvable within a reasonable amount of time. But being our newest solver, we are still actively working on it, trying to implement some editing workflows, as well as expanding it across that platform. So Krista, can you explain how the city is keeping up with my growing online shopping habits and collecting all the cardboard boxes from it?
Sure. Okay, just to walk you through, the waste collection scenario is something you're all kind of probably sort of familiar with. In the way that I have it set up in this demo, each truck actually will be able to collect both trash and recycling bins. So you notice some houses have one, some houses have both. Each bin is separated out in the truck and each has a different capacity. And that's just the model that we'll use for solving in this demo. Okay, so here in Pro, I have this houses layer and those are my stops. So I'm gonna start by going to my waste collection layer and importing those stops. So I will select houses from the dropdown, and then I'll map my fields. So for name, in this table, it's ID. Bins 1, which are my trash bins, I will map to waste bins, and bins 2 are my recycle bins, and I will map to recycle bins. Now I'll hit OK. And now I want to calculate service time for each house. So I'm going to open the attribute table for stops. And I will run calculate field on service time here. So for calculating this, we're going to calculate the service time based on the number of bins to collect, accounting for both waste and recycle. It takes 30 seconds per bin. So what I'm going to do here to calculate is add bins 1 plus bins 2 and then multiply it by 0.5, which is dividing that in half to get 30 seconds per bin. And we'll hit OK, and then you can see that service time field will populate there at the bottom. Okay, now I'm going to add our garage depot. So I'm going to go to the locate pane and just geocode the address of that depot, which is 2159 Chestnut, and I will right click and add to feature class. Then I will select my depots layer and hit OK. And then I'll just open the attributes table for depots and make sure that that got added. And you can see it got added with that address as the name there. So I'll close that. And I'm just gonna kind of clean up and go over to edit, clear my selection, save my edits. And then I will just zoom back out so we can see everything again. You can see that depot added there north of my neighborhood. Okay, now I'm gonna add information on the routes. Okay, so we have 3 trucks for this neighborhood. We want to select our start an end depot, which was designated with that name. That's our address. We will allow 450 max trash bins per truck and 325 recycle bins, and we'll hit OK. Then we'll open the attribute table for routes just to check that our 3 routes got added. They did, with the start and end depot name and our capacities that we added. Okay, now I'm just gonna adjust some travel mode settings. I'll come up here. Under U-turns, I want to expand U-turns and say U-turn only at dead ends and hit OK. And then for time, I'm gonna set a default time of day to start at 6 a.m. And I want a max total time of 360, which is in minutes, so that's 6 hours. I'm gonna set collection mode to one side at a time. It'll collect one side of the street before going onto the other, and I will hit run. And you should see our 3 routes pop up here in different colors. And we've got green, purple, and orange. I just want to show you one other way that we can view the output of this tool. If we click Route Report, it opens the ability to export a report to PDF. And this is just something that is a printable report that summarizes the trash collection routes that we can give to our drivers. Once that finishes, I'll just show you kind of what the PDF looks like. Close this to get a better view. And it just gives an overview of all of the routes at the front, some summary information on the routes, and then it will divide it per route. It'll zoom in a little bit on the single route, and then it'll break the route up into groups of stops just for easier viewing. So if a user doesn't have ArcGIS Pro on a laptop driving around in their passenger seat with them, they can have that printout to work from. Okay, back to you, Heather.
Great, thanks. I also want to highlight one more thing around the waste collection solver. We've been hearing the customer requirement of creating polygon features that show the region of each route. So as we gather more information on how these polygons should look, we have a few options available as a code sample. You can see the output from one of them here. The other option is if you provide parcel data, we merge those into polygon regions. We'd love feedback on this if you're using them, so please reach out. All right, now that we've gotten an overview of each of our 4 solvers that can be used for fleet routing, let's review when to use each of them.
Okay, Heather, could you explain why the route solver was the right one to use for a commuter demo?
Sure. In this case, the route assignments were predetermined. Rain was always going to go to coffee on a break, and Sandrine was always going to go to Lobster Sack, because that's where they work. But if you expand that problem a bit, maybe you've already done some territory design and have regions for your sales associates. The route solver could be used to route to multiple locations for each of those sales reps. The route solver is both quick and easy to set up and easy to solve, so these types are really good for predetermined routes.
So we stuck with a basic problem of just a starting location and an ending location for each route, but how might the problem have been expanded? How would we go about that?
Well, let's say we have 10, 20, or even 100 stops for each of these routes. The route solver could have then helped us decide the sequencing to visit all of those locations. And each of those locations could also have appointments, maybe something like the business hours for a clinic. For example, if you're a pharmaceutical salesperson, you should probably only go to a clinic when they're open. And if there are time windows in the problem, then it can be helpful to know when to start the day for each driver. I mean, if I can have 10 more minutes in the morning petting my puppy instead of waiting at an appointment, I'm definitely going to want to know that. A route solver can also easily be shared with a navigator and make it easy for the drivers to make it through their day.
All right, so what about the animal rescue demo? What made VRP the perfect solver for this one?
Yeah, in this case, we didn't know the route assignment and sequencing, and so that's going to exclude your route solver from our options. We were also very concerned about picking up those animals on time and getting them to the correct clinic for treatment. So this pairing option is only available in our VRP solver.
How else could this scenario be more complicated so that we could have extended this?
Sure, so I want to highlight just a few of the options here. VRP has the concept of revenue, which allows you to set priority on some order locations over others. So in this case, Let's say there's more animals reported than our drivers could collect that day. We could prioritize those that are not able to stay with their current supervision overnight and grab the leftovers the next day. Or maybe for specialties, this would also help us better direct drivers and vehicles to the situations where they're better suited. On the driver's side, this could be something like training for large mammals. We would want to make sure we only assign large mammal rescues to the set of drivers that have the training for it. Or on the vehicle side, maybe half of the trucks have cages with mesh sizes small enough for those small animals. We'd want to keep those assigned to the vehicles with the correct cages and keep those animals safe. This can all be done by setting specialties on the relevant order locations and the routes that can service them.
Let's talk picnicking again. Why was last mile delivery solver the best option for delivering the cheese boxes to the bakeries?
Yeah, we again wanted that route assignment and sequencing optimized by our solver, and the goal this time was to be as efficient as possible for delivering those boxes and hitting the time windows. This kind of pre-planning where the quality is really important is best handled by our use case specific solver last mile delivery.
What other complexities could we have added into that scenario and still make use of last mile delivery?
Yeah, we can make it a little bit more complicated. Maybe we're accounting for the cost of vehicles or drivers. Say you have a mixed fleet where some of the employees are full-time and they're gonna be paid anyway. And then you have the ability to bring in a few others, but you have to pay them extra. So based on the delivery demand for the day, the solver would put as much of the work as possible on those full-time employees, and that would minimize the cost of your day. We can also allow for accounting when a truck could leave the cheese shop or when it needed to be back. So say you have a batch of cheese that will only be ready at 5 a.m., meaning the truck that's going to deliver that cheese can't leave before it's ready. The orders that are getting that type of cheese would then need to be visited by a truck that left after it was ready, but other vehicles could still start earlier.
Okay, so this one might seem like a silly question, but why do we choose to use the waste collection solver for picking up trash in the San Francisco neighborhood?
Yeah, the main clue here is the density of the orders. To be able to get a decent quality for route clustering and with a reasonable solve time, the algorithmic work we did for waste collection makes it your best option.
What other features does the waste collection solver have that we could have included in that demo?
Yeah, waste collection has the concept of renewals. So this would allow a truck to completely fill its compartment partway through the day, but continue working by visiting a landfill or a transfer station that would then empty it. And if renewals are set up, we will also visit that location before heading back to the ending depot at the end of your route. You could also do some pre-planning to determine what to do if a driver calls out sick. Then the other drivers would already know how to collect and cover for them. Okay, we looked at 4 different solvers today and how to choose which one to use. And I know you all want to go to dinner now that we've talked about cheese and bakery shops, but if you could take a few minutes just to fill out that survey, I promise to read all 15 of them. There are lots of ways to connect with the developer community for Esri, and it's actually quite active, so please reach out in your favorite version. And now we'll open it up for questions. What are you curious about?
What if I want to make a snow removal planning?
So you want to adjust into snow removal,
Yeah.
snow plowing, yeah.
Which solver should I use?
Yeah, I think for that, our best option is waste collection. It will get you close in that you can go down each street edge twice, one on either curb. Even one-way streets will go down twice. But we do know snowplow routing typically has things like major roads should be visited more often, or a whole bunch of lanes. Maybe it's your highway and you have to have 4 or 5 lanes. We don't handle that, but waste collection is probably your best for snowplow. Yep. Other questions?
You account for traffic?
Can we account for traffic? That's a great question. We can account for traffic in our final route shape and directions. That's where we have enough capability to pull in live or historical traffic. When it comes to the optimization, we take the traffic data that we have and sort of neutralize it over the day. and do our best with that. It gets very complex if we try and have multiple IDs. Yeah. Cool. What else do we got? You look very curious over there. You got a question? No? Okay.
We're gonna start calling on people. No, if anybody wants to just come up and ask us a question here, you don't want to ask in front of the whole group, or if you want to reach out to us later by email or stop by the showcase tomorrow to see. We won't be here tomorrow, but some of our other colleagues will be, and they can get you in touch with people on the team as well. And we'd be happy to stick around and as long as you need us.
Yeah. Okay.
Thank
and
you.
You got the last up. Yep.